The derivative as a function. As we have seen, the derivative of a function at a given point gives us the rate of change or slope of the tangent line to the function at that point. If we differentiate a position function at a given time, we obtain the velocity at that time. It seems reasonable to conclude that knowing the derivative of the function at every point would produce valuable information about the behavior of the function. However, the process of finding the derivative at even a handful of values using the techniques of the previous section would quickly become quite tedious. So in this section, we're going to actually define the derivative function and learn a process for finding it in a much quicker way. The derivative of a function, f of x, denoted by f prime of x, is the limit as h approaches 0 of f of x plus h minus f of x all over h. So notice this is similar to the formula that we did in the previous section, but in this case, instead of having a values, a plus h, f of a, we're going to just call that x. So that way, once we find a formula for the derivative function, all we have to do is plug in those a values to get all the different values for the rate of change at multiple x values. Okay, so for f of x equals x squared minus 2x, find the following. F prime of x. Okay, so f prime of x, we'll use that formula we just were taught, the limit as h approaches 0 of f of x plus h minus f of x all over h. All right, I always do these as my little side notes so I don't get too much stuff in one spot. So let's figure out what f of x plus h is. So that's going to be x plus h squared minus 2 times x plus h. So that gives us x plus h times x plus h minus 2 times x plus h. So we get x squared plus 2xh plus h squared minus 2x minus 2h. That is super yucky. You hopefully remember, maybe you remember seeing this part of this formula. That's called the difference quotient. We learned that back in college algebra. We just didn't have the limit attached to it in front. So you've already kind of dealt with this algebra. All right, so let's substitute in what I just found for f of x plus h. So that's x squared plus 2xh plus h squared minus 2x minus 2h minus the function. So the function is x squared minus 2x. Make sure that we remember we're subtracting the entire function, not just the first term. So you've got to put that all in parentheses. A lot of students forget to do that. So that gives me the limit as h approaches 0 of x squared plus 2xh plus h squared minus 2x minus 2h minus x squared plus 2x all over h. I'm going to put a little box here. All right. So we're going to be able to see that we've got some things cancel out, which is great because now the only terms that I have left have an h in them, which will help me get rid of that 0 in the denominator. So I can factor that h out. And when I do that, I'm left with the limit as h approaches 0 of 2x plus h minus 2. So now I can actually substitute 0 in for h, and I'm left with 2x minus 2. So this means that a formula for finding the derivative of this function at any x value is this. So what's great about doing this is that now that I have a formula, I can easily go through and find the rate of change at specific x values really quickly because all I have to do is use this formula. So f prime of 1 is just going to be f prime of 1. So going into this formula, so f prime of 1 is 2 times 1 minus 2, so I get 0. F prime of 2, or negative 2. So that's going to be 2 times negative 2 minus 2, which is negative 4 minus 2, which gives me negative 6. So it's so helpful to have to actually find this formula for all x values, and then all we have to do is just substitute in the specific x values that I'm looking for. All right, let's look at another formula. So if I have finding the, for g of t equals 4t over t plus 1, find the first derivative formula, the derivative function. All right, so g prime of t. So that's going to equal the limit as h approaches 0 of f of, in this case, we're using t because that's our input values, or sorry, and this should be g since our function is g. So g times t plus h minus g of t all over h. All right, so the limit as h approaches 0 of 4 times t plus h over t plus h plus 1 minus 4t over t plus 1 all over h. Holy grossness. Okay, I'm going to just get this numerator multiplied out. So that's 4t plus 4h over t plus h plus 1 minus 4t over t plus 1 all over h. So this looks gross and your heart may be racing a little bit at this point. So just take a deep breath and know we're going to get rid of these fractions because right now if I substituted that h in, I'm going to end up being in that indeterminate form of 0 over 0. And so we learned in previous sections the problem-solving strategy for this. So if we have a complex fraction, you're going to multiply both the numerator and denominator by that least common denominator. So if I looked at this, that least common denominator is going to be t plus h plus 1 times t plus 1. And as long as whatever I do to the numerator, I do to the denominator, I'm totally fine. This is just my math magic, multiplying by a fancy, fancy 1. All right, so again, I always write out this step just because I have found if I don't, sometimes I can miss things. It's okay if you do not write out this step, but I just want to make sure that you're seeing where all of this is coming from with what happens. So I'm going to distribute this to every single term. So minus 4t over t plus 1 times t plus h plus 1 over t plus 1. And then that's all over h times t plus h plus 1 times t plus 1. Oh my gosh. Whew. Okay, so let's get rid of some fractions, which will be helpful. All right, so it looks like we've got, those are going to cancel there. So I'm left with 4t, so 4t plus 4h times t plus 1 minus, these are going to cancel here. So 4t times t plus h plus 1. And I'm going to leave this down here as it is. H times t plus h plus 1 times t plus 1. Okay. Take another deep breath. And let's go and FOIL some stuff out. So when I do that, I'm going to get 4t squared plus 4t plus 4ht plus 4h minus 4t squared minus 4th minus 4t. So again, I had to distribute this negative sign to each of these. And then that's all over h times t plus h plus 1 times t plus 1. Okay, so let's see what I can cancel out. These 4t's are going to be gone, or 4t squareds. These are going to be gone. And I've got 4ht and 4th. Those are the same. Remember that multiplication, you can actually, it's commutative, so you can do it in any order. So 4ht is the same thing as 4th, so those are going to be gone. And I'm going to be just left with 4h in that numerator. So 4h over h times t plus h plus 1 times t plus 1. So those h's are going to cancel out, and I've got the limit as h approaches 0 of 4 over t plus h plus 1 times t plus 1. All right, now I'm finally at a point where I can substitute 0 in for h. So I'm going to get 4 in the numerator, and then in the denominator, I've got t plus 1 times t plus 1, which is just 4 over t plus 1 squared. So there is that derivative function. So I'll write it all the way out. G prime of t equals 4 over t plus 1 squared.